Hello there, I'm Ashok. Today we are going to discuss the topic time and work. So we are going to complete this entire topic in five parts. Okay, today we are going to cover at least two, then we will cover the remaining parts tomorrow. See here, this is what we are going to do. In the first video, we are going to cover the intro, and if possible, we are going to cover these kind of problems. So I will explain one by one. So coming to different efficiencies, you may come across these kind of problems where the problems are going to be like this, where A can do a work in 10 days, B can do the same work in 15 days. He will ask you to find out how long they will take if both of them are working together. Okay, so if you observe here, if only A is working, he can complete the work in 10 days. Similarly, if only B is working, he can complete the work in 15 days. So whenever both of them are working together, the time should be less than 10 days. So you should not add or do any kind of calculation on the days. So then how you are going to solve the problems? So if you observe here, the speed of A is more than speed of B. Speed in the sense it's with what capacity he is doing the work. So capacity of A is much faster compared to capacity of B. So that is meant by different speeds or efficiencies. So in the first model, we are going to cover these kind of problems where each and every person is going to have different kind of speeds. Okay, coming to the next model, groups are equal efficiency. See here, then the problems are going to be like this. 10 men can do a work in 20 days, 12 women can do the work in 10 days. If 3 men and 2 women are working together, how long they will take to finish the work? Here, we don't know the individual time taken by each and every person, but we are treating them as a team. So, by default, what we are going to do here is we are going to assume time taken by first man is equal to time taken by second man is equal to time taken by third man, and so on. That means that we are going to assume that each and every person is going to have similar kind of speed or efficiency. Okay, so we are going to assume here every person in the group is going to have similar kind of speed. On the next one, joining and leaving, let us think like this. A and B started a work. After working for 2 or 3 days, A left the work. That means now only B is working. Then some may join in the work again, or again some may leave the work. That means in the entire process, some will leave the work, some will join here. So those kind of problems we are going to discuss on the third model. Coming to alternate days, let us take the problems are going to be like this. A can do the work in 10 days, B can do the work in 15 days. A started working alone and B is working on every alternate day only. That means that let us take first day A is working, second day A is going to take leave and B comes to work there. On the third day again B is going to take leave and A is going to again work. That means the pattern is A, B like this. If they are working like this on alternate days, how long they will take to finish the work? That's the problems on alternate days. And finally, we are going to discuss pipes and cisterns. So think like this, you are going to get similar kind of problems, but there is a slight difference. We are going to discuss on pipes and tanks. The problems are going to be like this. If you open tap A, the tank will be filled in 10 hours. If you open tap B, the tank will be filled in 15 hours. How long they will take to fill the tank if both of them are opened together, which is similar to different speeds of problems. Similarly, think like this. You are having 5 pipes on this side of similar pipes, and you are having 5 similar pipes this side. If you open these 5 taps, it may take 10 hours to fill the tank. If you open these 5 taps, it may take 15 hours to fill the tank. If you open 3 from this side and 2 from this side, how long they will take to fill the tank? It's like a group people. Like similarly, you are having 2 pipes A and B. If you open this one, it will take 10 hours to fill the tank. If you open this one, it will take 15 hours to fill the tank. Now what you are doing is, for the first 1 hour you are opening pipe A, for the next 1 hour you are opening pipe B. If you are doing like this until the tank gets filled, how long they will take to fill the tank? Like A, B, alternate days. So whatever the problems or whatever the techniques that you have used in time and work, the same techniques can be applied in pipes and cisterns. The only difference here is in pipes and cisterns you may come across leak. That means that in timed work, if you are doing any work, nobody is going to spoil it. But coming to pipes and cisterns, there may be a leak. Because of leak, some of the water may come out. So how long the pipes will take to fill the same tank by compensating this leak effect? That is the only extra point that we are going to learn in pipes and cisterns. Okay. Okay, without delay, let us see how to solve these kind of problems. Okay, you can solve these kind of problems in majorly in three ways. First one is by using per day method. Second one is by using LCM method. Third one is by using ratio and proportions. You can use any of the technique that you want, but majorly we are going to use LCM method. I will explain why. So come here. We are going to solve a simple problem to get better idea. Assume that A can do a work in 10 days, B can do the same work in 15 days. Now I want to find out how long they will take if both of them are working together. Now, one thing is very sure that you can't add the days, because if you add, you are going to get 25, which is not possible. Why? Because if nobody is helping, only A can complete the work in 10 days. If somebody is helping, the work should be done in less than 10 days. So, what you are going to do? So, for that one, I will give a simple example. Think like this. Okay, I can manufacture two benches in one day. Okay, two benches per day. My friend can manufacture three benches per day, like some normal benches. Okay, now if both of us are working together, we can make five benches in one day. Yes or no? That means that my speed is two benches per day, and my friend's speed is three benches per day. So if we are working together, we can add our speeds like two benches per day and three benches per day. The sum is going to be five benches per day. But you can't add the times. See here, my friend will take 10 days and I will take 15 days. If we are working together, it can't be 25 days. Okay, so you can add the speeds but not the time. So by doing something, you have to convert this time into your speed. Then you can solve the problem by solving the equations. So how you are going to do that one? We know that here speed of A is more than speed of B, and time of A is less than time of B. That means that we can say time and speed are inversely proportional to each other. Okay, so simply take the reciprocal of time value, you will get your speed value. Okay, so let's observe very carefully. We are going to discuss the per day method now. So let us take A can do a work in 10 days, B can do the same work in 15 days. Now take speed of A as 1 by 10 and the speed of B as 1 by 15. Whenever two people are working together, you can add their speeds. Remember, you can add the speeds but not the time. So whenever A and B are working together, the speeds of A and B are going to be added. So this is going to be 1 by 10 plus 1 by 15. As a result, you are going to get 30 as LCM 3 times and this is 2 times. You are going to get 5 by 30, which is equal to 1 by 6. So the combined speed of A and B is 1 by 6. But in our problem, the options are going to be in terms of days but not in terms of speed. See here, if you reverse the time, you are going to get speed. Okay, again, if you reverse the speed, you are going to get time. Like for example, if you take 10 days, if you take the reciprocal of that one, you got the speed of A. Again, if you take reciprocal, you are going to get the days. So take the reciprocal of time, you will get speed. Take the reciprocal of speed, you are going to get time. So the combined speed of A and B is 1 by 6. Then the combined time is going to be simply 6 days. If you observe here, the speed we have taken is 1 by 10. That is nothing but the amount of work that is completed in one day. That means if somebody can do the work in 10 days, they can do 1 by 10th part of the work in one day. That's why we're calling it as per day method. So I will just repeat it once again. Pay attention everyone. So In the problem, he is going to give like this: A can do a work in 10 days, B can do the same work in 15 days. Now he will ask you to find out how long they will take if both of them are working together. So one thing you should not do here is never add the times, okay, but you can add the speeds. So what you can do is, by doing something, you have to convert these times into speeds. How you can convert them? Simply take the reciprocal of the times, you are going to get your speeds. Whenever two or more persons are working together, you can add their speeds. So speed A and B are working together, you can add the speeds of A and B. So speed of A is 1 by 10 and speed of B is 1 by 15. Then combined speed of A and B is 1 by 6. But I want combined time. Simply take the reciprocal of your answer, you will get combined time. Okay. So that is the first way, which we call it as per day method. Okay. Next we are going to talk about LCM method. Now think like this: A can do the work in 10 days, B can do the same work in 15 days. We need to find out how long they will take if both of them are working together. So what you need to do here is, first of all, you need to convert your time into speed. But in LCM method, what we are going to do here is, we are going to take, or we are going to assume the total work here. Okay, remember one thing, you can take any number, but we are going to take LCM. I will tell you why. For example, first I'm going to solve in a difficult way, then you will understand why we need to take LCM. So assume that A can do the work in 10 days and B can do the work 15 days. Then take any random number as your total work. For example, I will take 20. Let us take, I want to do 20 units of work. This is the value that you have assumed. You can take any number you want. So let us take, A can do 20 units of work in 10 days, B can do 20 units of work in 15 days. You just need to find out how many units they can do in one day. If A can do 20 units in 10 days, means he can do 2 units per day. Similarly, B can do 20 units in 15 days. 20 units in 15 days. That means that he can do 4 by 3 units per day. If both of them are working together, if A and B are working together, A completes 2 units and B can complete 4 by 3 units. As a result, 6 plus 4, 10 by 3 units per day they can complete together. That means if they work for one day, they can complete 10 by 3 units. But to complete all the 20 units together, how long they are going to take? They are going to take 6 days. Simply do the cross multiplication like this. Okay, you will get your answer. But here the difficulty comes is, you are dealing with fractions. So to eliminate fractions, if you observe carefully, here you are dividing this middle number 20 one time with A's days, one time with B's days. Instead of taking some random number, you will take such a number which will cancel both 10 and 15. So I will tell you why and how. Now we are just slightly going to modify the problem. Think like this: A can do the work in 10 days, B can do the same work in 15 days. Assume the LCM of both these numbers as total work that you need to do. That means 30. That's the LCM of 10 and 15. Assume that 30 units is our work. That means the work that we need to complete. A can complete 30 units in 10 days. That means 3 units per day. B can complete 30 units in 15 days. So B can complete 2 units per day. That means if they are working together, they can complete 5 units in one day. So in one day, together they can complete 5 units. To complete entire work, they need to complete all the 30 units. How long they are going to take? Simply cross multiply, you will get 6 days. So the advantage of this method is, if you observe here also we are taking per day work as the speed. In the previous problem also, we are taking the per day work as, see here. Here, if you observe here also we are taking per day work as speed, but here we are dealing with fractions. That means if somebody is joining in the problem or somebody is leaving the problem, every time you have to add or subtract the fractions. Okay, which is very difficult because at each and every step you need to deal with fractions. But if you come to the LCM method, Here we're simply dealing with round figures. That means if A is joining, you are just going to add 3 units per day. If B is leaving, you are just going to subtract 2 units per day. Then that means that you no need to deal with the fractions. That's why we are mostly going to prefer this LCM method. Okay, for the next two problems, I'm going to solve in all the three methods. Okay, but later on we are going to use only LCM method. I will just repeat once again. And one more thing, everyone. Every time saying units is somewhat difficult, so assume chocolates. I will explain once again. See here, in the problem they are going to mention like this: A can do the work in 10 days, B can do the work in 15 days. Now what you need to do is take the LCM of both the numbers as your total work. Assume that I'm having a packet. In that packet, I'm having 30 chocolates. Assume like this. Now change the problem slightly like this. A can complete the entire packet in 10 days. B can complete the entire packet in 15 days. How long they will take to completely empty the packet together? That's the same as the previous one. Now see, we're having 30 chocolates here. A can eat all the 30 chocolates in 10 days. That means he can eat 3 chocolates per day. B can eat all the 30 chocolates in 15 days. That means 2 chocolates per day. If they are eating together, they can obviously complete 5 chocolates in one day. Now, if they're eating together in one day, they can eat 5 chocolates. But if they want to complete the entire work, they need to empty the entire packet, which is 30 chocolates. How long they will take? Simply cross multiply. You will get your answer. So remember, from this moment onwards, whenever I'm saying total work or work need to be completed means they need to empty the entire packet. That means they need to empty the LCM number of chocolates. Okay. Now we are going to the last method, which is ratio and proportions. Now see here, we are going to take the same problem, but we are going to solve in ratio and proportion method. A can do the work in 10 days, B can do the same work in 15 days. We know that speed and time are going to be inversely proportional to each other. Similarly, if you multiply speed and time, you will get the total work also. I will explain with a simple example. Let us take, I can construct 5 buildings in one day. If I work for 10 days, that means I have completed 50 buildings. My speed is 5 buildings per day. I worked for 10 days, that means I have completed 50 buildings. So whenever you multiply your speed with the time, you are always going to get your total amount of work done. Similarly, I can eat 10 chocolates per day. I have eaten for 5 days. Then I can say I have completed 50 chocolates. That's it. So whenever you multiply your speed with the time, you are going to get your total work. Now see here, what you need to do here is take the time ratio of A and B. So it's actually 10 is to 15. So then what will happen to my speed ratio? My speed ratio is going to be 1 by 10 is to 1 by 15, which is reciprocal of the time ratio. But multiplying or dividing the ratio with the same number, it is not going to affect the value of ratio. That means I'm going to multiply both of them with 30. 3 times, this is 2 times, and this is 3 times. That is 3 is to 2. That means 1 by 10 is to 1 by 15 is same as 3 is to 2. Remember, multiplying or dividing the ratio with the same number is not going to affect the value of ratio. Now simply multiply speed and time, you will get your total work, which is 30 in both the cases. That means with the speed of 3, A can complete 30 units in 10 days. Obviously, because A speed is 3 units per day, he worked for 10 days to complete 30 units. Or with the speed of 2, B can complete the entire work in 15 days because total is 30. Every day he is doing 2 units. So you can say that he can complete the work in 15 days. So now write the same thing. Speed into time is total work, which is equal to 30 units in our case. Now who is working? A and B are working together. So A speed is 3 units, B speed is 2 units. You can add the speeds but not the time. So if they are working together, they can do 5 units, 3 plus 2. 5 units in one day. So with the speed of 5, how long they need to work to complete 30, which is equal to 6 days. So you can use any of the methods like per day method, or you can do with the LCM method, or third one is ratio and proportions. But my choice is always go with LCM method. You can use ratio and proportion only when there is a comparison. Like A is 30% faster than B. So A can complete the work in 10 days less time. In those kind of cases, you can't find out the LCM. So in those cases only go with ratio and proportion method, otherwise only use LCM method. So we are done with our first part intro. In the next, we are going to discuss the problems on different efficiencies. Thank you.